Okay. Um, so we have just a couple of little short things to do today, and then we'll split out into breakout rooms so that you can get some work done and some practice done. So super simple day, but yeah, a couple of things that we need to get through. So uh, we're going to work on synthetic division, which is an additional way of doing polynomial division that is different from the box method. It will give you the same results as the box method, but if you're kind of a hater of the box method, this is another option. And then I'll show you kind of what's going to be on the assessment for next Tuesday when I give that out to you. I just have some screenshots that I can share with you of what that looks like, not with the problems written, but like I'll show you what the questions will look like. And then we'll do a little practice. So that's that. So um, we have one more week. Maybe you saw me typing this slide up just now. But we have one more week until this quarter is over. And that means that you have that much time until the uh, late work needs to get turned in. Your need to do list of assignments are these ones. So if you go to Google Classroom and you look at, the Google Classroom page and it looks like this, and then it's right here and you go to classwork, the numbers right here along the left side are the day numbers. And so if you need to find out what's on day 4, you scroll down to find day 4 and it's right here. And that's a must do assignment. I don't really have a way of highlighting those on Google Classroom, but I just wanted to give you this list. I sent this out on the announcement that I've made today too. So these 11 assignments, maybe it's 12, I don't know, I don't remember accounting, but it's 11. Those you have to do, okay? If you would like to schedule a meeting with me, I just posted a link in the chat. You can click on this calendar page, click here, and then you can choose a box, a gray box. And then when you click here, you'll get an ability to like set up a meeting with me. So that's Monday and Tuesday of next week, just if you need to check in with me or if you need a little help with a little something that you're behind on. So that's that. I did send out an email to those of you who have not done the chapter 4 assessments yet, because those are like, you have to do those. And otherwise, if you don't do those, I can't get a grade for you. So that's that. And so make sure you do those. There is a meeting that I emailed out for that assessment exclusively on Monday morning. So make sure that you know about that. If you can't make it, just email me. Okay. All right. Let's switch over to here. We don't have a lot of new information today, but I'm going to show you one new strategy to do polynomial division, and it's called synthetic division. And it's called synthetic because it like removes all the variables, and so it like synthesizes the important information. It's like a weird name. But basically what you need to do is you need to write out the list of the coefficients in standard form. So 1, -8, 0, -5, and 30 of the stuff you're dividing. Notice that I put this 0 here because there are 0x squareds written right here. So there's 0x squareds there, so you need to make sure you represent every power of the polynomial. Okay. We're dividing by x minus 8, and x minus 8 is the factor that corresponds to the answer x equals 8. And so therefore, we are dividing by the factor called 8. And so that's why we put the 8 in the corner of the box over here. Now we have this procedure where when you work down, you add. And when you work diagonally across, you multiply. And I'll show you what I mean by that in a second. So you kind of create this equals bar and you work your way down. And when you work your way down, you add. So you write 1 plus 0 is 1. Then you take your 8 and multiply by 1 to get 8. And so if you add down, then you get 0. Then you multiply across and you get 8 times 0 is 0. Add down and you get 0. Multiply across and you get 0 because 8 times 0 is 0. Then you add down and you get -5. And then you multiply across and you get -40. And then you add down and you get -10. This right here is the remainder. And this represents the quotient. And so if you think about what this is, these are coefficients on the polynomial. And so if we know this, it's in standard form. The last term is -5. This means that we have 0 x's. This means we have 0 x squareds. And this means that we have 1 x cubed. So this is a new way of doing polynomial division. It's faster, but it kind of is a little bit removed from reality of like what we're doing. And so I would encourage you to stick with box method, but this is a little bit faster. So if you're trying to be like the type of person who wants to save a lot of time, you can get this. So our answer here is x cubed minus 5, remainder -10. And remember, if you were, curious about why we care about remainders, if you put in 8 for x into this polynomial, you will get -10 out. That's the remainder theorem. That's a little bit from last week, I realized, or I guess earlier this week. But yeah, that's the remainder theorem. And that's synthetic division. Okay, let's just do one more synthetic division example. This one we should not get a remainder out, but we'll see. So coefficients are 4, 11, 0, and -12. The factor we're dividing by says that x equals -2 is the factor or the x value that you're putting in. So you're going to put in -2 here. This is like the spot where you would put the a, the x minus a, the thing that you're dividing by, right? The thing you found on the graph as an x-intercept, for example. Okay, so we add straight down, we get 4. We multiply across, so -2 times 4 is -8. We add straight down and we get 3. We multiply across, we get -6. Add down, -6. Multiply across, and we get 12. If you add straight down, then you get 0. And this last spot right here is the remainder. And because we got 0, I'm happy about that. Oh, come on. But what that tells me is, hey, you know what? I got a 0 remainder. The remainder is 0. So if I put in -2 to that original polynomial, that cubic polynomial right here and right here, you will get 0 out. But also it tells us that x plus 2 is indeed a factor of that cubic polynomial because we got remainder 0. Our answer to this polynomial division problem is -6, and then there's this 3x, and then there's this 4x cubed, or sorry, x squared. So you work right to left. I don't know if I'm pointing right to left or what, but you point right to left what the increasing degrees of x are. Okay, so this is our answer to the division problem with no remainder. So that's a little bit faster. It's a little bit different from how we did box method. Ultimately, it will give you the same answers, and I honestly don't care which method you use. If you're like vibing with this and you're like, yes, this is the one, great, that's fine. If you're like, nah, man, this is weird, let's just do box method division, that's also fine with me. So stick with that if you're happy with that. Okay. Here's some screenshots of what Tuesday's assessment will look like. This is day 31. And so I just want you to be very prepared about what you are going to be expected to do on this assessment. This first question says, find all the real zeros, maxima, and minima. So those are the extrema, right? Those are the turning points. So that's where you would put that. Give the window you use to show the features and attach a picture of what your calculator screen shows. So if you're using your TI-84, great. If you're using Desmos, that's fine too. What you would need to do is remember that there's a button on your TI-84 called window. So you can press that button and adjust the window to show all of the graph. Your goal is to get your polynomial to all be in the screen. So you want to make sure all of the turning points are shown on the screen. You want to make sure all of the x-intercepts are shown on the screen. Okay. You will need to find all of the zeros. I don't know how many there will be. There could be up to 4, which means we could have up to a degree 4 polynomial. You have to identify, so this is second trace, and then option number 2. That's how you would do that on the TI-84. The turning points are second trace, and then I don't remember what the option numbers are, but it's maximum and minimum. Okay. On Desmos, remember that you can just be clicking on all of those options, so you can do it that way. If you are using Desmos, that's what you're going to have to experiment with a little bit. So you'll have to click this settings gear right here, and then you'll just change these x-axis and y-axis numbers so that you can show everything. Okay, great question. Thank you. Okay, the next part of the assessment is going to look like this. These are straight up polynomial division problems. This says you may use box method division or synthetic division for either problem. So there are 2 of these problems where you just have a polynomial divided by a potential factor. You have to find the quotient and the remainder, okay? It is legit that it's possible that you will have a remainder. It's also legit that your remainder will be 0. So both of those possibilities are within the realm of like what I might be giving you. So just know that that's possible. Okay, that's learning target 5B, by the way. 5A was the first problem. So these are the 2 types of questions I'm going to be giving you to assess learning target 5A and 5B. Learning target 5C looks like this, okay? And so this is the 3rd section of the assessment. The first one says you have to solve this equation that says 0 equals a polynomial. I gave you a hint that says one of the answers is A. Okay, so then you need to use the factor theorem, divide out that factor, proceed from there, right? You may, depending on the degree of the polynomial, that will tell you how many answers you have. Notice that I'm not telling you how many answers you should be getting. You need to know that by using the fundamental theorem of algebra. So that will be like how you do that. The other one, I'm going to give you a graph. I'm going to give you a very quick hint to you 26, 25, 24 students who are here. If you have something that looks like x squared, if you have something that looks like this, x minus 6, no, x minus 4, x minus 4, remember that there's a double root here if it touches but does not cross the graph at this spot. So that's just a little hint to you. Remember about double roots and multiplicity of roots. So if you need to go back to the very first or second lesson, I guess it is, about the factor theorem, that's where we learned about multiple roots. And so just be aware of that, okay? The last section is just a straight up polynomial equation that I have no hints built on, and you just have to figure it out with your own abilities. But remember, you can always start with the graph. So you can always be typing that thing into the graph and see what it looks like, okay? Okay, that is all of the stuff on the assessment. So if you're like, oh man, this is like totally good, then great, that's awesome. If you're like, oh no, then like email me. Sign up for one of those meetings with me, you know? Okay, moving. I am gonna open up some breakout rooms for the next like little part of class, and I know that we only have about 15 minutes left, but I want to show you just like some of the stuff for showing work on Google Docs. And so I'm going to open up this example here, which is this one. This is how I would do this problem on Google Docs. And I'm going to do just parts of it because I think parts of it are obvious, but there are a couple of things that I want to remind you of. First thing is you can insert an equation by clicking Insert Equation. I know it's crazy, but you can type in like that, like x to the See the to the button? It's right here. Or you can just do Shift 6. Shift 6 to get an exponent. X to the fourth, like that. Okay. The other thing that I might do is I might start with Desmos. So if I was going to actually solve this problem, I would type in x to the fourth minus 8x cubed plus 19x squared minus 24x plus 48. And I see this thing, oh, look, a double root. See that? It touches but doesn't cross the x-axis at x equals 4. So that means that I would start by dividing this polynomial by x minus 4. To do that, I'm going to insert a table to show my work. And I'm going to give myself some space, like, I don't know, 6 boxes. I'm dividing by the factor, and I'm going to center everything so it looks a little nicer. X minus 4, right? Because 4 is the answer. So x minus a is the factor. Okay, so I'm dividing by x minus 4. I'm going to use box method. So I'm going to make these boxes a little bigger so that it's like, oh, look, there's the box method. Oh, now it looks like box method. And now it's organized. So I can show my work in a way that is easier for me to read. And that's important because I have a hard time seeing some of your work sometimes. So I'm going to put my x to the fourth here. So I'm going to click new equation and just type x to the fourth. Up in this box, then I would need x to the third. Yeah, okay. Well, then I would have to have a negative 4x cubed here, right? Okay, so you can continue this division along like this. I just wanted to put this out here that like there are ways of you showing your work on Google Docs that are like better and easier for people to read if they're, for instance, grading them. Okay, that's enough of that. Okay, here is what we're going to do now. We're going to do breakout rooms. One of the critical parts of doing breakout rooms is you all have to be seeing the same thing so that you can all be talking about the same thing. And so the critical first step of a breakout room is one person volunteers to present their screen, okay? So click the present now button and then click the a tab button. You can choose what tab you want to be in, or you can choose entire screen. I don't really care what you choose. Open up the assignment from today and open up the practice problems. You will need to make a copy of this so that you can actually do it. Okay, so click file and then make a copy, and then you can make a copy of it for yourself. Okay, talk about it together. Someone needs to type on the document, but other people need to help. Okay, please try to record the work that you do on the document and then make sure everybody's name is on this document so that, like, you know, you can actually get credit for doing it. Okay, so I'm going to put you in breakout rooms now. I see a couple people are leaving. Okay, and then I'll bring you back in like 8 minutes at the very end of class. Set up breakout rooms. We want, let's do 8 breakout rooms. No, 7. Timer, 8. No, 9 minutes. Okay, go. Okay, I know that I only have like less than a minute left. So as you come back in, thanks for working on that. I know that it's the last week of school for this quarter, basically. So yeah, let's get it done. All you got to do the rest of today is to finish those practice problems and make sure you check your work against my answer key. Okay, turn those in, and yeah. If you want, you can check in with me and ask for help after this lesson. I'll stay on for a minute. And then will you just check in with everyone that you know that's in this class and be like, hey, are you caught up in Algebra 2? Because like a lot of people aren't. I'm just saying. And so just check in with them and be like, hey, well, let's work on Algebra 2 this weekend. And like see how much you can get turned in with them over the weekend because it's time. Okay, thanks. Have a great weekend. Work hard this weekend. If you are behind, come to my help sessions if you need them. That's it. Bye. Thanks, everybody.